Okay, so this is a video showcasing my encoder and decoder plus small storage, I guess, memory card in Minecraft. Um, it is a 4-bit system, so 4 bits, and so if you're not familiar with binary, um, if you take 2 and raise it to the power of however many bits, that is however many signals of ones and zeros you have in here. See, there's 4 lines. If you raise 2 to that power, that's how many different pieces of data or inputs that you could put into it. So 2 to the power of 4 equals 16, which is why I have 16 different inputs. And the way this works, basically, is that I have a torch configuration. This is essentially a logic gate. There's essentially an AND gate. And actually, that's more over here. This is really, I have a switch and an inverted signal, which again inverts these torches. And each one of these torch configurations matches the respective numbers binary code in 4 bits. So for instance, if I wanted to put in a 1, that would be 0, 0, 0, 0, and then that torch down there is 1. And then for 2 we have 0, 0, 1, 0, and so on and so forth. So if, for instance, I wanted to input a 10, which is 1, 0, 1, 0, I would flip the switch, these 2 torches come on, and it lights up the lines like 1, 0, 1, 0. And then these kind of redstone wires come down here and connect with their partners from down below, and it kind of takes a turn right here and heads for this switch. This switch can be turned on and off to engage or disengage the decoder. And the way the decoder works is it's a little more complicated, but basically all you have to know is it's the inverse of the encoder. It takes the 4-bit signal and converts it into a 16 input or output rather decimal signal. So the way this works, this has a bunch of AND gates underneath it, and they are each configured that each signal has to be exactly right for the given output, or else the circuit will not continue. So for 10, if I wanted to light up 10, let's see, 7, 10 right here, underneath you'll see that there is an AND gate in which the first one must be on, the second one must be off, the third one must be on, and the fourth one must be off, or else this line will not turn off, and this will not be inverted into a signal that can go over there. So if I wanted to put in a 10, we could see what would happen. And there you go. The redstone lamp next to number 10 lights up. This circuit continues all the way over here, and this is, I don't really know what to call this. I guess it's like a translator. Anyways, what it does is it, based on the position of the 16 outputs, it will trigger a piston that will kind of power a circuit right here, and it'll put a signal into this comparator based on the distance away from the comparator. Because as if you don't know, in Minecraft the redstone signal only goes 15 blocks. So it sends in a signal to this comparator based on the signal strength because of how far away it is, with 0 being no signal and 16 being the maximum strength of the signal. So we now have the 10th piston engaged. So if we wanted to save this to memory, I already have a little bit of memory in there going around and around. If I wanted to erase that, there's an erase function over here. So if I wanted to set erase to true, I put that, this piston disengages, it severs the circuit right here, and then when the signal eventually goes all the way around and reaches this line of comparators, it'll stop, and then it'll be erased. So if I wanted to wait until that's erased, bam, it's erased. Now I can go over here and set erase to false. And now I can input new data. So I have a 10 engaged, and now I can press this button. And once I press this button, it will trigger this redstone circuit, which will go all the way over here and trigger this. This is a 3-tick pulse generator, which means it's in game time in Minecraft. There's the time is kept in what's called ticks. Basically, a full second has like 20 ticks in this, which would generate a huge long signal, which would make it impossible to store a lot of information. So what this thing does is the signal comes through here, it goes through both of these things simultaneously, and while it does that, the piston gets triggered and shoots the block over, and then so that means the signal from here goes through instantaneously and gets held on this delay for 3 ticks, which means this piston is only triggered for 3 ticks. So it emits a signal that's only like 20 comparators wide compared to like, I don't know, or it's only 2 comparators wide compared to like 20, which means we wouldn't be able to store a lot of data. Let me set the time to 0 real quick. So if I wanted to save some data on this, I go over here and press save. And you see that, you could see it a little bit. And we see that's our signal now, and it goes in like a serpentine fashion all the way around until it gets to here, which is where this circuit is complete because we set erase to false. And then this is the reader, so the bit of information would come through here and it gets read based on its signal strength from the origin. So let's see, it had the 10th spot open right here, which means that this will go out to 10. You saw it. So for future things, I'll probably hook up another 16 output bus right here and hook it up to another encoder so I can get a nice binary circuit going through here. Same thing over here. I'll probably extend this out at some point with right here. This doesn't do a whole much. It kind of just goes in a big circle right now, but hopefully in the future I can connect some more things to this and actually put it to some good use.